So in this video, we are going to look at how we would find the distance given 2 points that when it's not just a nice vertical or horizontal line. So we have to do a little bit more work in this, but it actually has a lot of the same skills that we've used already this year. So in order to find the distance between 2 points that form a slanted line, what I like to do is I actually like to turn them into a right triangle. So if I were to look at this and just create the right triangle formed where the slanted line makes up my hypotenuse, then right here I could look and I could see that if I count here, I have 1, 2, 3. So the length of this side is a 3. And if I count the length of this line, I get a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I count here, I get 12. All right. So now this actually should look pretty familiar to you guys. So even though this is a video on finding distance, when we think about the Pythagorean theorem, we can use Pythagorean theorem to find the distance between 2 points. It just requires this step of drawing out the right triangle. So if I wanted to use Pythagorean theorem here, I could say a 3 squared plus a 12 squared equals an x squared. So if I go ahead and I just add these up, and this is a skill we actually just practiced, then I would say 153 equals x squared. And when I take a square root of 153, I get a 12.4. So that's actually one way we can use the Pythagorean theorem to help us avoid memorizing the distance formula. Now, the distance formula might have been the way you actually remember seeing this. And so if I just move this over, we can see this is how the distance formula actually looks. And maybe when you're seeing it, it's kind of reminding you of something you've seen before. But this formula right here is called the distance formula, where you have an x2 minus x1 squared plus y2 minus y1 squared, and you take the square root of the number that you find. If you were trying to use the distance formula, you would label your points x1, y1, and x2, y2. And so if I were to look at this, if we're noticing, I would have my x2 minus x1, so 10 minus a negative 2, and then you have a y2 minus y1, which is a 1 minus a 4. When you plug in these numbers, this is how you would get the same answer we found before using our Pythagorean theorem. All right. So here is with our Pythagorean theorem, and that's with the distance formula. Now, just because I want to also show you how we could skip kind of all the math and just use Desmos to do this. So if I wanted to use Desmos to do this, one thing we can do is you just go to your Desmos calculator, and what we were looking for in this problem was the distance between 2 points, negative 2, 4 and 10, 1. So if you notice here, I have those 2 points plugged in. So negative 2, 4 and 10, 1. Now I'm just going to type this in one more time so you guys can see how we did it. But what I do is I just say I want to call A negative 2, 4. And the thing I love about Desmos is it actually graphs it for you so you can see if that's kind of where you wanted it to be. And then you can say I want B to be the point 10, 1. So now I have my 2 points labeled. So what I love about Desmos and what's going to make our life easier this week is now you can actually type out the word distance, and you can say distance, comma A, comma B, and there's our answer in a third way. So hopefully in this video what you've learned is there's actually 3 different ways you can do the distance formula. 1 is Pythagorean theorem. 2 is using the actual distance formula. And 3 is just plugging the points into Desmos.